Okay, this is the fourth part in this series devoted to Improv Card Magic. Now today we need 10 card packets, and in particular we will need 3 piles of 10 cards each. So let's go ahead and just deal those out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. 10 random cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. 3 piles of 10 random cards each. Now, if you've been watching this series at all, you know what happens next. What we're going to do is we're going to look at each of these piles one at a time and decide on what particular structure to go with for the reveal. And once the cards have been mixed thoroughly, we will reveal the pairs that we made note of at the beginning. Okay, and for the first pile here, we're free to choose any of these packet structures, whichever's the strongest, I suppose. And then as we narrow it down, we're kind of stuck with whatever we're handed here. Okay, so let's take a look at the first packet. And as always, we'll quickly look for any AMP structure of interest. That's normally the easiest one to spot. So AMP is where we take them in pairs, starting from the top. So here, wow, we got 2 hearts. There we go. So 2 hearts, that's nice. 2 black cards, different suits. Opposite color, opposite color. Ooh, another black pair. So if we went with the AMP structure, we would have 1 red pair. In fact, it's matching suits, in particular hearts, and then 2 matching black pairs, and the other 2 pairs would be non-matching colors. Okay, so that's pretty interesting and fairly strong. So that's the AMP structure. Why don't we go ahead and look at the mirrored structure? And if you remember, this is where we look at the outer ones, and these are in a mirrored relationship. So if we view this as a mirrored structure, when we mix it, these 2 will be paired together, opposite color. These 2 are opposite color. These 2 the same color, different suits. These 2 opposite color, opposite color. So that's not bad either, because really all of them are of opposite color within the pair, except for that 5 of spades and queen of clubs. Okay, what about the 2-cycle structure? Is there anything interesting there that might be stronger? I'll go ahead and just kind of jog these so that you can kind of focus on the 2-cycle structure here. So let me just move these around here a little bit. Okay, so if you remember how this works is the first card in this first set of 5 cards, we say the first cycle, is related to the first card in the second set of 5 cards. So those are related by position, and those are of opposite color. Oh, wow, these are both hearts. That's nice. These are both black, which is good, but not the same suit. Oh, here we go. We got another pair of suits matching, and then we got opposite color. So as a 2-cycle, we would be able to match up the 3 of hearts and the 9 of hearts, along with the jack of clubs and the king of clubs. And we would also be matching up the black 5 with the black queen. So of those, which one do you think is the strongest? Okay, and you might have a strong opinion about that. I think what I'm going to do is I'm going to do something very different today. So what I'm going to do is I'm going to, and you can watch me here, I'm going to write down something over here. I'm going to write down 8. Okay, and now you could do this on a piece of paper as well if you're going to have a hard time remembering all these numbers, which you might actually. And then I'm going to write down 16. And as you write these down, you can have the spectator watch you if you like, or do it without them watching. Just kind of hold the paper close to you and jot down these numbers. And 21 and 15, or 16 that is. Now I want to show you how you can turn a mistake into a strengthening element. Okay, so it ends up that the 15 here, I don't know how to count, is incorrect. It's supposed to be a 16. I'm going to leave that on my notes and have that as another fun little twist at the very end. Okay, so I'll have you wait and see what meaning these numbers have. It might be that you've been able to figure out where I came up with these numbers, and if so, kudos to you. If not, that's okay. You'll see in just a moment. But this is something that can be easily done. Okay, so I wrote those down, jot those down for future reference there. Okay, so this will be our AMP packet, so I'll kind of line it up with this column here. Okay, now the next packet could be used as a mirrored packet or a 2-cycle. We'll just wait and see how strong things are. Okay, so let me just put this out here and just see what we find. Just for practice, even though we've kind of taken up our AMP for the sake of the presentation today, but we can just quickly take a look at that. So as an AMP, these two are, let me just jog them, these two are of opposite color, those two are of opposite color, these two are the same suit, that's kind of nice, and then these two opposite color, and these two are of opposite color. So what you could say if you went with this is at the end, all of the pairs, all 5 pairs, would be of opposite color except for one. And it wouldn't be too much to remember that it's the ace and 4 of spades. All of the other pairs, taken from the top, will be of opposite color. Okay? So if you consider that we have 1, 2, 3, 4 red and 6 black, for you to see in your mind's eye that they're all of opposite color except for one, and then you're able to name the one that stands out as different, namely the ace of spades and the 4 of spades, that would be mind-blowing to any spectator. Okay, so an AMP structure could be used here. Now we technically kind of used it up, so let's go ahead and look at the mirrored structure here. So this is where you look at the outer ends. The outer cards are in a mirrored relationship relative to position. So you have the Queen of Hearts, 2 of Spades, opposite color, same color but different suits. Oh, here we go. We have an Ace of Hearts and a 4 of Hearts. That's nice. So same suit, and look at this. We have that same 4 of spades and Ace of Spades, still related, but now viewed within a mirrored relationship. Isn't that nice? Okay, so just to remind ourselves, so we have opposite color, so same color, different suits. They're both black, and then we have 2 reds and 2 spades. Okay, so we could go with that. That's fairly strong. You can say that you've matched them up where one pair is a pair of hearts, one pair is a pair of spades, and then there's some other black pair as well, but they don't match in suit, and then the other pairs don't match in color. Okay, so that would be one way to kind of think about it. But let's go ahead and take a look at the cycle situation as well and see if that might be a little more interesting even. Okay, so this is where you break it off into a group of 5 cards. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, right? And now, oh, that's nice. So the 2 of spades and the Ace of Spades are related by position. So if we view this as a 2-cycle, we would reveal them as a pair at the end. We have a red 10 and a red 4, different suits. Okay. We have a black 3 and a black jack of different suits. And then we have different colors here for the 8 and the 4, and then different colors here for the 4 and the queen. Okay, so here if we were to go with this as a 2-cycle structure, we could say there are 1, 2 black pairs, and one of them is a set of spades, and then there's 1 red pair, and those are of different suits. Okay, so I mean that's fairly strong as well. But I may do something a little different here. I'm going to jot down 5 numbers again, and if you want to see if you can figure out, what these numbers refer to, that would be great. If not, I'll clearly explain, what they're referring to at the end. Okay, so here are our 5 numbers that I've written down, and these would perhaps be a bit difficult to store in short-term memory. So having a little piece of paper and just jotting down, you can always claim things like, well, I'm just jotting down the identities, or I'm just jotting down information about the cards that you actually randomly chose, which is true. And then we're going to mix them and have you mix them. Actually, as a spectator, you're going to make all of the important decisions. Okay, so here are the numbers that I've written down. Now this time I don't believe I've made any mistakes, so we'll just leave it as is. Okay, very good. So this is going to be viewed as a mirrored packet. Okay, excellent. Okay, and now we're kind of boxed in here. We've used up, for the sake of this presentation today, we've actually used up our AMP example, our mirrored example, and now we just hope that this packet has a fairly interesting 2-cycle structure. Well, whether it does or doesn't, we'll find out in just a second. Okay, so we're going to look at the 2-cycle organization of these cards and just see what we can find. So the 5 and the 6 are related by position. They're both black, different suits. The 2 kings are related by position, both red, different suits. Very interesting. Oh man, look at this. Oh, every once in a while I look ahead to see what we have, and I'm just blown away. And then we have black. We have an 8 of clubs, a 10 of spades, so both black and different suits. And then we have a 10 of clubs with a 7 of clubs, okay? Both black, same suit, interesting. And then the final little pair that's related within a 2-cycle organization of the cards will be the 6 of diamonds and the ace of diamonds. Wow, isn't that nice? Okay, so just think about what we've done here. So we've matched up, we will be able to match up all of the cards by color. Okay, so if you want to just remember that, and if you feel like that's enough for you to remember, and you don't want to overload your brain, you could stop there. But if you're able to also just remember that not only are they all matched up in color, but we do have a pair of clubs, namely the 10 and 7 of clubs, and a pair of diamonds, namely the 6 and ace of diamonds. Okay, so if we can simply just remember that they're all matched up by color, great. And if you can make note of the fact that you actually have exactly 1 pair of clubs and exactly 1 pair of diamonds, this will be a very, very strong ending. Okay, so let's just make note of that. So we'll just say all pairs match within each pair in color. And then if you can also remember, you have a pair, I'll abbreviate it, a pair of clubs, and then what was the other pair? A pair of diamonds. Now, I think it may be asking for too much for someone to remember all of the card values, or very many of the card values. You might be able to remember that we are matching up a 7 and 10 of clubs and an ace of 6 of diamonds. And if you're able to remember that as well, then that is amazing. And it will just strengthen the reveal, I believe. Okay, well, we have our 3 structures that we will be using now. Okay, and so what we're going to do is I'm going to switch the pieces of paper here. Okay, because underneath I have the mixing that we're actually going to go through for each of these separately. And as I've done before, this is not necessarily, well, this is in no way unique. I just kind of decided on a few paths to follow. Okay, so let's see. It's hard to know where to put things until I get things settled, but you'll just have to trust me that I'm not going to be changing. I'm not going to be changing any of the packets, and there's no reason to, because I've already made note of what it is we're going to be doing with each of them. So you already know what we've committed to. So let me just put my little pin in here to try to keep the paper from sliding every which way. Okay, so what I'll do is maybe I'll kind of put this one, well, let's just do it this way. I'll just put this one up here for now, since we're going to focus on the AMP structure, and maybe that'll help us focus our attention here. Okay, so this is our AMP packet. Okay, so as you may recall, all I've done here is I have simply, so let me bring up our basic shuffle list here. So what I've done is I've simply chosen a path to follow, and all of these involve random choices that we can give the spectator, and they can decide how key things are done. So we're viewing this as an AMP, and so the first thing that we'll do is a mange. Okay, so if you're starting to get these structures down, you can probably know what's going to happen. Sorry, I'm being OCD here. This is going to drive me crazy. I have this new pad here and it's just sticking everywhere. Okay, so what does a mange shuffle do to an AMP? So come over here on our list. That's line 13. Well, what does a mange do to an AMP? Well, recall that it converts it to a mirrored structure or packet, okay, which is what we have marked right here. Okay, and now if you remember, the mange comes in two varieties, an over-under and an under-over. And you can give the spectator that choice, because in the end, both of them will convert this to a mirrored structure relative to the pairings that we made note of at the beginning. Okay, so you could ask the spectator, I'm going to do kind of a fun shuffle. It's called a mange shuffle, and it comes in two varieties, an over-under or an under-over. Which one would you like? And maybe they'll say under-over. Okay, so how this works is you move the one card to your other hand, and then you go under, over, under, over, under, over, under, over, under. So that is a mange under-over. Okay, that takes us to a mirrored structure. Now, you'll probably remember that mirrored packets have a whole bunch of shuffles that will preserve them. Okay, the most famous among them is just the LR shuffle, left, right, left, right, left, right, with random stacking of the left pile on top of the right, or the right pile on top of the left. It's a free choice by the spectator. Maybe they'll ask for right on left. Now, I do want to point out that we can do as many of these as you like. This left-right shuffle. Okay, and maybe this time they'll ask for left on right. That's just fine. So do as many of those as the spectator would like, but all of them will preserve the mirrored structure itself. Okay, and now we're going to do something called a supercoat. Now recall, what does the supercoat do? It's over here. It's line 6 up above. It's similar. It's essentially a 50% coating of the cards, in which you can freely choose to stack the left pile on top of the right, or the right pile on top of the left. That's the only difference. Okay, and that will convert a mirrored structure to a 2-cycle structure. And interestingly, it's one of the few shuffles that will also go in reverse. That same shuffle will convert a 2-cycle structure to a mirrored structure. Okay, so that's kind of cool. Okay, so what you do is you go 1, 2, 3, 4, 5, drop these on the table, and now the spectator's free to stack left on right or right on left. Maybe it'll go left on right. That's just fine. Now it's guaranteed to be a 2-cycle. Now once it's a 2-cycle, you know that cutting the cards randomly, have the spectator decide how to cut them if you would like, will preserve 2-cycle structures. Also a Charlier shuffle. This is where you do top to bottom, bottom to top, top to bottom. I have a separate video on the Charlier shuffle if you want to look it up. Okay, this is a very convincing little shuffle, and it preserves 2 cycles. And then the next one that we actually haven't used yet in this particular series, it's found near the very bottom, 25 on our list. It's called an FL squared F. And that is an acronym for the first shall be last and the last shall be first. Okay, so how this works is you begin dealing out the cards into piles until the spectator says stop, and then you deal into another one until they say stop. Okay, deal into another one, maybe they say stop there, and then deal into another one until you run out of cards. And now you stack from right to left, which is true to the name. It's called the first shall be last and the last shall be first. So you're just stacking them in the opposite order to which they were dealt. Okay? Now it ends up that this rather complicated looking little shuffle, it preserves all 3 structure types, as you can see down below. Check that out. Isn't that nice? Okay, so the FL squared F, it will preserve a 2-cycle structure, a mirrored structure, and an AMP. It leaves it unharmed. Now it ends up that this FL squared F is technically a packet reversal. It just reverses the order of the cards. Well, all 3 structure types that we look at, if you reverse the order of the cards, it will not harm the fact that it's of that certain structure type. So why don't we go up here? Where's my mouse? I'm using my left hand for this. So I've come down here and just imagine essentially reading these lists, you know, the 2-cycle, mirrored, and AMP. Instead of from left to right, read it from right to left. Well, will it still not be of that same structure? So if you read a 2-cycle structure from right to left, it will be 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. That is a 2-cycle. There is a pattern that repeats twice. And similar for the mirrored structure. In fact, for the mirrored structure, it looks identical. Because if you come down here and read this from right to left, it's 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, which is exactly the same if you do it from left to right. Okay. And then for the AMP structure, reading those in reverse order will not change the fact that it is actually an AMP structure. That in pairs, they are related in the way that you've designated at the beginning. Okay? So anyway, this will preserve all 3 of them. Okay, so just keep that in mind. And it's especially nice to use if you have quite a few cards, 10 or more cards, because then you can deal out quite a few little piles and then you stack from right to left. Okay, now the next one, we have used it before, but it might not be one that you're super comfortable with because I don't think we've used it that many times. It's at line 23 right here. It's called the LR to the negative R. Now the negative R is there to remind us of the kind of dealing that we will do. Okay, so an LR, negative R, is as follows. You just need to make note of how many cards you have, namely 10. Divide that in half, that's 5. So what we're going to do is we're going to deal out 1, 2, 3, 4, 5. So that's the same. Now, instead of putting this one here, you go in reverse order. You go 1 here, 2, 3, 4, 5. Okay? So that's what that negative r is telling us to do. We'll go 1, 2, 3, 4, 5, and then you go backwards 1, 2, 3, 4, 5 in terms of dealing them. Okay? And now you can stack these from left to right or from right to left. So have the spectator decide that. Just say, okay, how would you like me to stack these from left to right or right to left? Okay, maybe they'll say left to right. Well, what that is guaranteed to do, as you can see on the chart there, on line 23, is it converts a two-cycle structure to a mirrored structure. Okay, so we're back to a mirrored structure. Okay, and now I'm asking us to just do an LR deal, but don't stack. Okay, and we've done this sort of thing before. And if you remember, what this gives us right here, these two together, these will now be, quote, mirrored piles. Okay, and then you may remember that if we have, quote, mirrored piles, we can do something special that's quite fun. It's called the swapping procedure. Okay, you remember this from a previous video? Okay, so here what you do is you just make note of, okay, how many cards do you have in each half? Well, it's 5, of course, in each. So that number of cards minus 1, so 5 minus 1, which is 4, is the number of swaps that we have at the beginning of this process, okay? And the spectator can freely allocate those swaps however they would like. So we have a total of 4 swaps. So maybe they'll want 1 swap here. What's a swap again? This is where you move the top card to the bottom. That's 1 swap. So we've used up 1 out of the 4 that we have that we can spend. And now we can do the other 3 here. 2, 3. And then what you do is you just set aside this pair right here, just set aside that pair of cards. Now we have 3 swaps left because there's 4 in each. So maybe they'll want 1, 2 of them applied there, and then we have 1 swap left we can apply to that one, and we just set aside that pair. We have 2 swaps left. Maybe they'll want both of them over here. 1, 2, that's just fine. Set aside this pair like that. And then we have 1 swap left. You want it on the left? Okay, so we'll go like that. Set aside this pair like that. And so that gives us our pairings. So here we have our pairings. Okay, so what we may want to do is, I'm trying to make some room here so we can see what we're doing. Okay, so here are our pairings. I'll just have them sideways there so you can keep them separate from these other piles of 10. Okay, so do you remember, well, you probably don't remember, but you probably remember that I wrote down numbers for this first one. You remember that? I wrote down 5 numbers. Okay. Now, I decided to not tell you exactly what those were representing right from the start, but you'll find out here in just a second. Okay. So, so there's a few ways to proceed. You could state now what will happen, or you can flip these face up and the spectator will look at the cards and go, what am I to get from that? I mean, what does that tell us? And then, you know, kind of bring out your slip of paper and go, oh, that's interesting. I wrote down something about these cards. And so maybe we'll do it that way. Okay, so why don't we go ahead, we'll just say, okay, let's see what pairings you've come up with. You know, given all of those random choices made by you, the spectator, where did that bring us in the end? Okay, so where are we here? Okay, so let me just, that, and maybe I'll put this one down here, I suppose, I don't know, just to, okay, there we go. Okay, and you can ask the spectator, okay, do these pairings mean anything to you? And they'll, I don't know, they'll probably say no, that doesn't seem to be anything special. I guess you got a couple of hearts matching there is all, but and then you can bring out your little note Say, well, that's interesting. I jotted down, and this is when you can tell them what the meaning is. He said, I jotted down what these pairs of cards would add to, what their values within each pair would add to. I wonder if I got any of them right. Well, I have an 8. Do any of these add up to 8 in value? Let's see now. Oh, got one right here. That adds to 8. I also wrote down 16. Do any of them add up to 16? I don't think so. Oh, right here. Right? 5, Jackson 11. 5 plus 11 is 16. Let's see, what was the other one? Oh, I wrote down 11. Do you see a pair that adds up to 11? I do, right here. 9 and a 2. Those add to 11. And then I have a 21. Do any of these add up to 20? Oh, let's see. A queen is a 12 plus 9. That's a 21. We nailed that one too. And then my final number, see, I had a 15. Does the remaining pair add up to... well, the remaining pair is this one, I believe. See, king is 13 plus 3. That's 16. It's not 15. Wait a second. Here, I'll show you my piece of paper. I actually wrote 15 and then I crossed it out and wrote 16. Is that what they add up to? They do indeed. How in the world, working together, were we able to do that? That is absolutely amazing. Wow. Please teach me how you did that. Okay, so that is the AMP presentation. Okay, and so now you know what the values represented from the very start. So when we had those, you had that packet out, and I just looked at them in pairs, and I just quickly added up their card values within each pair. Here, that was a genuine mistake. I don't know why I added 13 and 3, and I initially got 15, and then I looked at it again, I thought, well, that's not right. It's 16. So you can turn it into kind of a fun little twist at the end. So that was not intentional, but you can work it into the performance seamlessly if you would like. Okay, so that is the presentation dealing with the AMP structure that we noted at the very beginning. Okay, very good. Okay, well, why don't we work with the mirrored packet next? We still have our 2-cycle up here. Okay, so if we view this as mirrored, and that's how I viewed it at the beginning, I wrote down some information here if you remember, based on this packet, and secretly it was based on this packet while viewing it as a mirrored packet. Okay, so that's why I came up with these particular numbers. Okay, so the thing to just realize is, if we're wanting to preserve the pairings that I made note of, I wrote down information about those pairings that I want to be correct in the end, I need to treat this as a mirrored packet. Well, what does it mean to treat it like a mirrored packet? That means you need to apply shuffles that either preserve mirrored packets or convert it to other known packet structures that you can then either preserve or then convert those to others, and then eventually convert it all the way back to something that is usable, that gives you your special pairings. Okay, kind of like we did here with the swapping procedure. Okay, so since this is mirrored, as you know, the stay stack principle is in force. And so when it comes to mirrored constructions, there's a whole bunch of different shuffles that will leave mirrored packets unharmed. Now, it will move the cards around. The cards will be changing position, but they will be maintaining a mirrored structure among them, okay, a mirrored relationship. Okay, so what I recommend here, you wouldn't have to, but I thought, okay, well, we can do an even or odd up jog. Those preserve mirrored structures, and you can see that on line 11 right here. So why don't we do an even up jog? You can actually give the spectator the choice. You can say, would you like me to do an even or odd up jog? So let's do an even. So this is where you push forward or jog forward the even position cards. So I'm jogging forward the card in position 2, 4, 6, 8, and 10. Okay, and then you just strip those out, those cards. Okay, these were in the even positions, these were in the odd positions over here, and the spectator is free to tell you how to stack these, and it will still preserve the mirrored relationship among the cards. So maybe they'll have you put the right pile on top of the left. That's just fine. Okay, so this is still mirrored. Now think about it. The stay stacked principle allows you to deal out a packet of, if it's a mirrored pile, mirrored packet, you can deal out the cards into any number of piles where that number of piles is a divisor of the packet size. So for example, for 10 cards, the two divisors are 2 and 5. Okay, now we've already dealt a mirrored configuration of the cards into 2 piles, left, right over here, but we can also deal it into 5, since 5 also is a divisor of 10. So what that means then is you can just deal them out like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and we can do random stacking from left to right or right to left. So just ask the spectator which of those two they would prefer, and it is a free choice. So this is still mirrored. Okay, now what we're going to do is we're going to Klondike pairs to the table. Now, you probably remember when you do that, you get something called a DMP. Okay, so a DMP, if you remember the larger hidden structures diagram that we showed you earlier in this series, a DMP is off here to the right of a mirrored packet. These are mirrored packets here. So if you come over here, straight over, you'll see that there's a K. It's probably small, but that's a little K right there, Klondike. So if you just Klondike pairs either into a single pile or into distinct piles, which is what we're going to do here, you get something called a DMP. And so really what you would be doing is you would be grouping together again the pairs that you made note of at the beginning, the ones that have a special relationship that relates to these numbers I wrote down at the beginning, right? Okay, so if we Klondike pairs to the table, we technically will get what's called a DMP. Okay, so we'll go ahead and do that. Now think about it. Once you have a DMP, what can you do with those pairs? I mean, because they're already the special pairs of interest. So let's go ahead and do it first. So I'll put a pair there, maybe a pair way down here, maybe one over here, one up here, and then one in the middle. Okay? So these are the exact pairings that I made note of at the beginning. Well, guess what that allows you to do? Think about it. Maybe I'll put this one up here. So once you have a DMP, you can randomly stack these pairs. This is far more powerful because with some of the stacking, we might say left to right or right to left, that kind of thing. Here, the spectator can freely stack the pairs however they like. So you can say, well, which pair would you like me to pick up first? And maybe they'll say that one. Which one next? This one. Then this one up here. And then the one down here. That's fine. And then the one up here. Okay. Well, think about it. What will this be now? What kind of structure will this be? If you randomly stack these distinct mirror pairs, will you not now have an AMP? Will it now not be the case that in pairs taken from the top, these will be the special pairs that I made note of at the beginning? Okay, so this is really an AMP now. So we're right here. So once it's an AMP, there's a whole host of things you can do. I'm recommending that we do this RLR. Do you remember that? RLR. The first R there is for, quote, random. So RLR will convert an AMP to a 2-cycle. Okay, and what's interesting here is that's all this one does. It won't help us in any other way. Okay, and it's a pretty powerful little thing, mixing, because you're giving the spectator a random choice that really seems like it should make a difference. Well, it ends up that it doesn't, because this is an AMP. Okay, so what is an RLR again? Okay, so remember, this is where you just do a left, right. Now, instead of going left, right again, left, right, the next level, you can put this anywhere. So maybe you want it there, but then you do need to finish that level, the second level. This one can go either side, have the spectator tell you where, finish that level. This one can go there, this one can go there, and then just, finish each level as you go. And now if you stack these in either order, this is a 2-cycle now. So you have a 2-cycle structure. Well, once it's a 2-cycle, you can do random cuts, which is wonderful, or a far more impressive is the Charlier shuffle, top to bottom, bottom to top, top to bottom, bottom to top, and do as many of those as you like. It won't hurt this, okay? And now what we're going to do to kind of finish is I've drawn a little diagram here, a little pentagon. Not a very good one, but the idea is you're still into 5 piles, so maybe you can do like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Well, think about what that's going to do. If this was a 2-cycle structure, that's where you have like a 1, 2, 3, 4, 5, followed by a 1, 2, 3, 4, 5. You have a repeating pattern. Well, if I go 1, 2, 3, 4, 5, I've put the first 5 cards all on different levels. Now the next card is technically associated with that first one I put down, namely a 1. So it's like putting another 1 here, another 2 here, 3 here, 4 here, 5 here. Well, you've created a DMP. You've created distinct mirrored pairs. Okay, you're back to the pairings that you want. Okay, and so at this point you can reveal that. Okay, now we did a similar. I did a similar thing with numbers, if you remember. So maybe this time, why don't we do it a little differently this time than I did it for the AMP. I'm just kind of moving these. Okay, so do you remember what I did here? So this is for mirrored. That's what we started with. So you could bring out your paper and say, well, for some reason, as I was just looking at those cards, I could hear in my mind's eye a sequence of 5 numbers, kind of like 5 random numbers. So I thought, maybe I should write these down. The universe is trying to tell me something. Well, the first number I wrote down is a 24, and at this point you can show them the list so they can check it in a minute. So 24, and then I wrote down a 40. It's kind of weird. 33, and then a 32, and then a 4. Where do those come from? Okay, and so with that little piece of paper kind of sitting out, you can now reveal what you see here. Okay, so we have these 2 here, these 2, and then these 2, those 2, and finally these 2. Okay, well, think about the numbers that I just mentioned. A 40 was one of them. You see a 40 hiding in here somehow? Or how would those numbers be related to these? And so you can maybe get the spectator started by just pointing out something. You say, well, one of the first number I wrote down was a 40. Well, I guess what's kind of interesting is 4 times 10 is 40. Well, that's kind of curious. What was the next number I wrote down? Oh, I guess the first number I wrote, sorry. The first number I wrote down was a 24. Didn't remember that, right? So is there like a pair here that somehow kind of relates to the number 24? Well, there is, right? The 2 and a queen. A queen is 12, right? A 2 times 12 is 24. That's kind of interesting. What was the other number? I wrote down a 40. Oh, wait a second. 4 times 10 is 40. No way. There's no way that these are all right. What was the next one? 33, 32, and 4. Is there a 33 out here? Where's the 33? 3 times 11. 33. Is there a 32? 4 times 8 is 32. And then I think the last number is really small. It was like a 4. Oh, wait a second. An ace normally counts as a 1. 1 times 4 is 4. I cannot believe it. Those 5 numbers that I just kind of felt had some connection with these 10 cards ended up giving us the exact products of the card values within each pair. Do you know what the chances of that are? Extremely small, right? And they'll agree with that, okay? So anyway, that's another little way to use your knowledge about these cards and being able to preserve the cards in pairs throughout quite a bit of mixing, in which the random choices that are offered are outside of your control, and the spectator is free to stack pairs however they want, or stack from left to right or right to left, or do an even up jog, an odd up jog, or maybe do a mange, over, under, over, you know, whatever it might be. And especially with this one here, you know, if the spectator kind of thinks back how they decided to kind of like stack those, they would think, man, if I had only changed even one of those decisions, this thing would not have worked out the way it did, would not have worked out perfectly. I would have foiled him. Well, it seems like that should be true, but it is not true, because an RLR will always convert an AMP to a 2-cycle. Always. It's guaranteed. Okay? So there's many places, if they think back in time and think, oh man, if I had just chosen a little differently, this wouldn't have worked out, you know, and that would be a very reasonable conclusion to draw, even though it's wrong. Okay? And the mathematics shows that it's wrong. Okay? The mathematics guaranteed that you would succeed, actually. Okay, and then the last one, we imposed a 2-cycle structure on this one. And if you remember, this was like the amazing, well, I think they're all amazing, quite honestly, but this was really, really nice. All pairs match in color. You know what the chances of that are. And then if you can just point out the fact that they all match in color, but not necessarily suit, but 2 of them do. There's a pair of clubs and there's a pair of diamonds, and you know that, okay? And then if you happen to remember the values, is it 7 and 8 and 1 and 6, or ace and 6 or something, that would be great. But the key is to not push the details to the point that you get yourself all confused and then everything comes crashing down. Okay, so it might be safe just to stick with this. At the very least, you can say they all match in color. That's amazing. And then 2 of them match in suit. I think it's clubs, and then there's a pair of diamonds. Okay, and that would be just spectacular if you stop there. Okay, well, this is a 2-cycle. At least that's how we're viewing it now. So once it's since it's a 2-cycle, you can immediately go into a Charlier shuffle and have the spectators, you know, tell you how many of those to do. And then if they're, you know, you want them to feel like they had a real part in it, you can say, well, why don't we just cut the cards? That way none of us know exactly, you know, the top card, you know, where we're starting with all of this. That would be fair. That would be fair, but not make a difference. Okay, so it's a 2-cycle still. Okay, now what we're going to do is we're going to use the LR inverse to create, technically, if we don't stack these, you could almost write down an intermediate step of a DMP, kind of like right here where we had distinct mirror pairs. But here I just make note of the fact, I was running out of space here, just randomly stack the pairs. Randomly pairs. That was supposed to say randomly stack pairs. Sorry about that. Okay, so what is the LR inverse? Okay, well, maybe to contrast it, now I guess we did it right here, come to think of it, at the very end. This is where I did 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? It's the same thing. Now the difference between that and an LR to the negative R is you go 1, 2, 3, 4, 5, and then go in reverse order, 1, 2, 3, 4, 5, the other direction. That's the only difference. Okay, so let's go ahead and just do that, and we can just do it in 5 piles if you like. So you just go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Though it might be aesthetically more interesting to put it in a circle of some sort or a pentagon. Okay, and now, as before, you can have the spectator decide how to stack these. Which of these would you like me to pick up first? This one, okay. The one on the far right, okay, very good. The one over here, that's great. Now, if you notice here, we have to be a little careful. Okay, can you see the ambiguity? I'm assuming this one goes there, right? Maybe this one next, and then this one next. Now, I do want to point out this is a brand new deck out of the box, so they just slip and slide everywhere. Okay, so assuming we didn't switch cards, which will destroy things, we should be on track still. We'll find out. Okay, so this is an AMP. Being an AMP, you can apply a mange. Remember, that's line 13 over here. And that will convert it to a mirrored structure. So come over here, AMP to a mirrored. And remember, the mange comes in 2 varieties, over, under, over. So maybe they'll ask for an over, under. Okay, so you push the top card to the other hand, and then you go over, under, over, under, over, under, over, under, over. That's called the mange over-under. Now, it's guaranteed to convert an AMP to a mirrored structure. We could do a lot from here if you like, because once it's mirrored, you have the stay stack principle. So you can do an LR shuffle, randomly stacking left on right. You can deal into 5 piles, randomly stacking from left to right. You can do up jogs. You can do 2 identical overcoats. You can do a Pharaoh shuffle. All of these are all different shuffles over here. You see where the M in the middle column? These are all different shuffles that will leave the mirrored structure alone. But here, I just recommended, okay, it's mirrored. Let's convert it, surprisingly, back to an AMP, okay? And I want to point out that there's nothing sacred about the particular path. I just chose a path. I tried to choose kind of a different organization of the shuffles as we go through these. But as long as you follow the table on the left, and you either know that you're preserving a certain structure type or you're converting it from one to the other, it doesn't matter exactly how you go through, as long as you perform acceptable shuffles at each stage to accomplish what it is you're hoping to accomplish, okay? Okay, so it's mirrored right now. Now, it is true, and we haven't used this one yet for this purpose. If you come over here, so a Bessie 1-1, if you look at the table, it's on line 15, so it's right there. So B11. Now, what this will do is it does a couple of wonderful things. It will convert a 2-cycle to a mirrored structure, always. And it will always convert a mirrored structure to an AMP. Okay, so this is, it looks similar to the Klondike, but it really is a different shuffle giving you a different ordering of the cards. That's the important thing. Okay, so what is a Bessie 1-1? Well, it's a shuffle that doesn't have a name out there, so I just gave it a name. I just call it Bessie B11. So this is where you take the top card off, 1 from the top, 1 from the bottom, 1 from the top, 1 from the bottom, top, bottom, top, bottom, top, bottom, okay? So you're just taking 1 from the top and bottom alternately, and that will convert it to an AMP, so we know it has that structure. And then an AMP can be converted to a 2-cycle by way of an up jog, even or odd. So isn't that nice? So if you come over here, an up jog is 11, so line 11 right there. And then if you come over, you'll see that you can convert an AMP, which is what we have, to a 2-cycle, okay? So we can do an odd or even. So if a person asks for an odd up jog, now what that would mean that's different is you would push forward the odd position cards. Now the very top card is in position 1, which is odd. So so that's card 1 being jogged up, card 3, 5, 7, 9. Okay, so that's technically an odd up jog. Okay, so you have to strip those out. Oh, that one goes on top. Sorry about that, I wasn't focusing. Yep, I think I'm fine. Okay, so you just strip them out, and then the spectator is actually free to stack these however they would like. So maybe they want the right one on top of the left. That's just fine. Okay. Now, generally, I find it easier to do the even up jog, and you can see for the reason that I just showed you. Because if you do an even up jog, you have the top card that's helping to hold in place the second card and so forth. So you're just less likely to maybe drop things or something. And it ends up that an even and odd up jog are identical, except for the order in which the packets, a left and right packet, will be stacked. Okay, so an even up jog in which you stack left on right is the same thing as an odd up jog in which you stack right on left. It's exactly the same thing, actually. So you could always just do even up jogs if you would like. It's a 2-cycle. Now we can go back to an AMP. Kind of funny that we're just kind of going back and forth between those, but you have to realize the spectator doesn't know any of this. They don't know where you are or what's happened or what each shuffle is going to do to the structure. In fact, they don't even know what structure you have in mind or even what these structures are. Okay, so the Pharaoh, so if you can see the Pharaoh shuffle, it's line 12. One of its purposes is it will convert always a 2-cycle packet to an AMP. Okay, so what's a Pharaoh? And this could be a Pharaoh in or a Pharaoh out. Both of them accomplish same thing, even though the cards are slightly ordered differently. But it will convert a 2-cycle to an AMP. Okay, so how does the Pharaoh work again? Well, this is where you just split the cards kind of so you can see them, see all of them. And then you take maybe the bottom 5, you split the cards in half, like 2 packets, and then you perfectly interlace them. Now, technically, one interlacing will give you an in shuffle, and the other one will give you an out shuffle. But since both of them are equally efficacious in accomplishing what we want, it actually doesn't matter if you do a Pharaoh in or a Pharaoh out. This will now be an AMP. Now, once it's an AMP, there's a really nice shuffle that will always preserve that. And it's right here. It's line 16. It's called a Bessie 2-2. So it will leave AMP structures alone, which is what the chart is showing us here. Okay, so what's a Bessie 2-2? Well, it's like a Bessie 1-1, but now you move 2 cards at a time. So you go 1, 2 from the top, 1, 2 from the bottom, 1, 2 from the top, 1, 2 from the bottom, 1, 2 from the top. That's the last card, goes on top. So that will preserve AMP structures. And now what we're going to do is we're going to do something called a pairwise transpose, but as noted here, but don't stack the piles, because these will be the pairings that we'll reveal. So a pairwise transpose, how does that work again? Well, it's on the chart, it's abbreviated P, I guess, P transpose, pairwise transpose, but it leaves mirrored structures and AMP structures alone. It won't harm them. Okay, and that's what we have here. So we have an AMP, but what we're going to do is we're going to do, quote, the shuffle, but not the stacking. Okay, so what's the pairwise transpose? This is where you deal out 1, 2. It's like you're switching the order of 2 things. That's what a transpose means. 1, 2, 1, 2, 1, 2, 1, 2. Okay? Sorry, these really are sliding all over the place. Okay, and then we said don't stack them. So why don't we go ahead and I'll just lay them out so we can see underneath our paper here in a second. Okay, maybe like that. Okay, so here are our pairings. Okay, and then this time you probably would want to just state what you believe and what you sense is the case here. Okay, so do you remember what we I mean, I remember, but do you remember? So all of these within each pair are of the same color. You remember that? But we have a pair that matches in suit, namely a pair of clubs, and we have a second pair that matches in suit, and it's a pair of diamonds. And if I remember right, the diamonds are the ace of diamonds and 6 of diamonds, and the clubs, I can't remember for sure if it's a 7 of clubs, 10 of clubs, or 8 of clubs or something, but we'll find out in a second. So that might be pushing it as far as how much information to remember. So I didn't really recommend that you remember that much. So this much will be enough. All pairs match in color, which is amazing. And then you can say, well, I think one of the pairs is a pair of clubs, and the other one, diamonds. No, I think it's diamonds. I think it's diamonds, okay? And then you come over here and kind of check to see if you're correct, okay? So look at that. We have a pair of matching color pair there. They don't match in suit. Okay, do we have another color matching pair? Oh, we do indeed, but they don't match in suit, which is what we said for some of them. What about here? Oh, here we go. We said we'd have a pair of clubs. And I think I maybe said 7 and a 10. Okay. Wow, we got that one. There's no way that we got these other. Oh, look at this. It's another matching pair in colors, but not the same suit. And then what did we say for the... Yeah, didn't we say... Well, we said all of them would match in color, okay, which they have so far, and that we would have a pair of clubs. And then I think we also said that we would have a pair of diamonds, and I believe it was the ace and 6 of diamonds. Are we right? Oh, we are indeed. Look at that. How in the world, once again, were we able to do that despite all of the random free choices that you made along the way? How could we have gotten to this point? And how could I have sensed that the cards were paired up in just this particular way? Isn't that amazing? I wonder if we could do it again. Yeah. And of course you can do it as many times as you like using whatever structure that random packet happens to have that's of interest. So thank you for watching, and take a look at other videos in this series, and especially other videos on the Hidden Structures channel. Thank you again.